Hello everyone, I'm going to do a complete walkthrough of the week 3 assignment. It is very unfortunate that we are doing this remotely because these are complicated things, and if you were doing it in class, I know that it would be a whole lot easier. So props to you guys for trying to work on this at your own homes and struggle through the issues. It does get easier as you practice more. I think the most important thing, the most important help that you can get on your own without asking us questions is this quick reference sheet. A lot of these problems are very difficult to think about unless you have this particular picture in your head or sitting on a piece of paper next to you. But if you do have this as a reference, like you print it out and you sit it next to your computer as you work problems, a lot of the problems are a lot simpler. So let me just give you a quick highlight of some of the things here, and then we'll do solutions to the problems. So whenever you're working in the grid, remember that each location here is its own separate variable that contains a value. And down here, as an example of how you would either look and see what value is in a certain location in the array, or assign a new value to a location excuse me, in the array. So if your two-dimensional array is named R, the way you access a particular location inside the array is by saying the row number and the column number inside square brackets like this. So if I say R34, that's referring to the number that's in row number 3, column number 4, right there. Remember, rows are kind of like horizontal lines, and as row numbers go up, your horizontal lines go down. Columns are these kind of vertical things here. Just like normal arrays or array lists, the location numbers always start with 0. So up here, when we're creating a new int array, where it says 11, that means that there are 11 total rows, but as you can see, the row location numbers go from 0 to 10. Same thing for columns. There's 6 total columns, but the way that you access them is with numbers that start at 0 and go up to 5. So it's always the last location is always one smaller than the total number of locations that there are. Maybe that's enough for the moment. The only other thing is on the back here, there's this looping pattern that's very, very common. It happens all the time, and I want you to practice it. This is looping over all of the row locations. So the first for statement is saying, like, let's start my row location at 0. Let's add 1 to the row every single loop. And let's keep going as long as the row number is less than array.length. And array.length is the total number of rows. So as long as my row location number is less than the total number of rows, I'm still at locations that are valid and inside the array. So now I'm thinking, all right, so I'm looping over every single row. For each one of those rows, you're going to loop over every single column inside that row. So if we go back to the picture, it's like when I'm at row 0, I'm going to loop through all these column numbers while row is 0. And then I move to the next row, and I do it all over again. I loop through all the column numbers while the row number is 1. So that's what this double for loop is doing. It's looping through every combination of row and column numbers that takes us to every location in the grid. And then once I'm looping over all the locations in the grid, then I can do something. And in this example, I'm just assigning random numbers there. All right, so let's dive into the problems. So the first problem says make array. It says given a number of rows and a number of columns, we should create a new array that's that size, and then fill it with the value that's given in the input here, val. So if I'm going to create a new array, let's give this just a second. Boy, this is going to happen to us a lot. So int bracket bracket is how I make an array. I'm going to call mine grid. I say new, and then int. And then what goes inside these brackets is how many rows and then how many columns. So if I did 10 and 3, that would be 10 rows and 3 columns. The number of rows is the same as the height. The number of columns is the same as the width. In our example, row is telling us the height and col is telling us the width. So I just use row and col here. Then what I want to do is I want to loop over everything. And I forgot what I was saying. I paused it and then did a bunch of stuff. All right, so let's loop over every location and assign value there. So we want this same pattern that's in the notes on the back page here, this loop over everything pattern. So row is 0, row is less than grid.length, because right now my array is called grid, r++. Then for column starts at 0, column is less than, if I say grid 0 is saying let's access the entire row at location 0. So this by itself actually returns a one-dimensional array, looks like this, that represents the entire first row. And so if I ask what is the length of that one-dimensional array, the answer is the length is the same as the number of columns. So that's the typical way of getting the width of a two-dimensional array, is you get one of the rows out and then you ask that how long are you. And then C++ to increment the columns. So now I'm looping over every single row and column, and what I want to do is I want to take my grid at the row and the column and assign the value to it. And then don't forget, at the very, very end, you actually want to return the grid that you created. So let's run it and make sure that it passes all the test cases. Okay, and it does. Let's do the next one. So the next one is called isSquare, and we're trying to test if an input array is square or if it's a rectangle. So I think the most popular thing to do wrong in this problem, come on thing. Okay, so I think the most popular thing to do wrong in this problem is to try and loop over all the locations the way that we were before. But think about it this way. If I called you on the phone and I said, hey, I've got an array whose height is 10 and whose width is 3, is it a square? You could immediately say no. And notice that you didn't have to know what values were inside the array. I never told you what values were inside the array. So you never actually have to loop over any locations at all. All you need to do is ask the array itself, what's your length, what's your width? So if we're going to store these into separate variables, let's call it height. I think that's less confusing. So height could be array.length. Width would be the first row's length, which is the number of columns. And then I could say, like, if height is the same as width, I know it must be a square, so I can return true. Otherwise, I'll return false. If you wanted to make this shorter, instead of saving these into their own variables, height and width, you could just take the expressions themselves and compare them directly. And now you don't need a height and a width. What the heck? Oh, I see. Like that. And we talked maybe once before. Notice that if this if statement evaluates to true, I'm returning true. And if this statement evaluates to false, I'm returning false. So really I can just return whatever that expression evaluates to, and that's the same. So this is like an ultra short way of doing the same thing. Okay, for this problem, it says return true if all four corners contain the same value. So let's get the value out of all four corners. So upper left is going to be array 0, 0. And this is where it's good to have the picture in your head. Here's 0, 0 is the upper left. Let's do the lower left. So the lower left is still in column 0, but the row is the last possible row. So here's where you see here accessing the four corners of your array. We need to get the height of the array and subtract 1. Because the total height of the array is how many rows, which in this case would be 11. And if you subtract 1, that gives you the location of the last row, which is 10. You also see I've written it here. Grid.length minus 1 is the last row number. Over here, grid 0.length minus 1 is the last column number. So here, if I have lower left, I want to use the last possible row number. So that's array.length minus 1 for the row number. But then the column is still 0. If I want to do the upper right, that's row 0, because it's in the top. But the column number needs to be the last possible column. So that would be array 0.length minus 1. And then for lower right, it's the last possible row and the last possible column. So array.length minus 1 and array 0 dot length minus 1. If you're thinking that this looks super ugly, you are not wrong. It is pretty ugly. If you prefer, there's a slightly nicer thing you could do. You could say last row is array dot length minus 1. Last column is array 0 dot length minus 1. And now, instead of having these ugly expressions in here, you could say give me the value at the last row, column 0. Or, in this case, row 0 and then last column. Or, in this case, last row, last call. And that maybe reads slightly nicer. Okay, so I've got all 4 of these values, and I want to test if they all contain the same value. So here's probably an easy way of doing this. I could say if lower left doesn't equal upper left, I know they don't contain the same value, so I'll return false. If upper right doesn't equal upper left, then they can't all contain the same value. If lower right doesn't equal upper left, they can't all contain the same value. So in other words, I'm comparing all of the corners to the upper left corner. If all 3 corners are the same as the upper left corner, then that must mean they're all the same as each other also. So in that case, I know they're all the same, and I can return true. That would be one way of doing it. If you wanted to, you could have the if statement say if lower right equals upper left, and also upper right equals upper left, like this, then return true, otherwise return false. So you could type that out the rest of the way, and that would also work. All right, so in this problem, it says new val. So I'm given an array, I'm given a location, a row and a column, and I'm given a value to put into that location. But here's the dangerous thing. It says in the comment, it is not guaranteed that the row and column provided are actually in the array. So someone running this command might give us an array that's only 2 by 2, but ask us to access row 7, and there is no row 7. So in order to be safe, we actually have to check first to make sure that the location is in bounds. So if you wanted to check if it was in bounds, you could check to see if the row is between 0 and the last row. So you could say if 0 is less than or equal to row, and row is less than or equal to array dot length minus 1. So that's asking, like, is row between the first and the last rows? And you could do the same thing for column. What I like to do instead is I actually like to test all the ways that the location might be outside the grid. So maybe it's outside the grid because the row is too small. So if row is less than 0, I know it's going to be off the grid. So I'll immediately just return the original array unchanged, because that's what it says it should do. If it says if the location isn't in the grid, just return the original array. So if the row is too big, if the row is greater than or equal to array.length, I know the row number is too big, so in that case, I'd also just return the array. If the column is too small, I just want to return the array unchanged. If the column is too big, if it's greater than array 0.length or equal to it, again, I'll just return the array unchanged. So now I've tested for all 4 ways that the location could be not valid. It could be it could be sort of above the top or below the bottom, or off to the left or off to the right. So I'm imagining it this way: off the top, off the bottom, off to the left, off to the right. If it's none of those things, I know it must be valid, and so I'm safe to use that location and assign the value there. And then at the end, I'll return the changed array. That's it. Let's look at the next one. So in this problem, okay, so this problem seems very similar to the last one. It says, given an array and a location in the array, add 1 to the existing value there. And again, it's not guaranteed that the location is inside the array. So if they're not, then leave the array unchanged. So let's just copy our bounds checking from the previous problem. And now we can say array row call. And instead of assigning a new value, what we want to do is we want to take the existing value at row call and add 1. So remember, when you have a single equals sign, you evaluate from right to left. So I take the current value, I add 1 to it, and then I take that and I save it back inside the one that was there. And then at the very end, I have to return the array again. That's it for that problem. So this is sort of similar to the first problem and the one that we just did. Here I've got an array, I've got a value. I want to loop over every single location in this array and add the value. So here we've got that pattern where row starts at 0 and it goes to the end. And then call starts at 0 and it goes to the end. And then I want to take array at row column, but instead of assigning a value, I want to take the current value that's there and add this input val and then reassign it. And then at the very end, after all the looping, I'll return array. Okay, so that's that problem. So this is very similar to the last one. Here I have an array and I have a value, and I'm supposed to count how many times does this value happen inside that array. So let's go and grab the solution to the last problem and modify it. So I already know that this double for loop is looping over all of the locations, except I don't actually want to assign new values. Instead, I want to have an if statement to test. So I'll need a counter to count how many times I've seen the value. On the inside, I'll look at array row column and see, is it equal to val? And if it is, then I want to add 1 to the counter. And then at the very end, I can return whatever the count is. And that's it for that one. So these last two are going to be useful for your actual grid game this week because they involve taking a location and then doing things with neighboring locations. So it says return the sum of the elements to the left and the right of RC. And by RC, I think we mean row column. So it's like we've got a grid, we've got a location. You're going to ask the grid what number is inside that location, but then you're also going to ask what number is to the left of that location and what number is to the right of that location. You're going to add all those numbers up and then return it. Let's think using this picture. So if I am in this grid and I'm given the location 3, 4, I'd get the number right here, but I'd also want to get the number here and here. So notice that all the numbers here are in the same row. So the number to the left is the same row, but the column number has gone down by 1. And the value to the right is in the same row, but the column number has gone up by 1. You might be worried what happens if they give you a value at the edge of the grid. Then if you try and go right, you've gone off the grid. And that's a great thing to worry about, but it says in the problem that it's guaranteed that those elements will exist. So we told you in the problem, don't worry about being on the edge there. So let's do it. I'm going to get the value out. Array row call is the val. Then let's get the value directly to the left. So the row is the same, but the column is 1 smaller. And now let's get the value to the right. The row is the same, but now the column is 1 larger. And let's return the sum of value plus left plus right. So that's it for that problem. So this one's very similar, except now we're not trying to add things up. We're trying to return true if the value at the location is touching another value that's the same. And we're going to check above, below, and left and right. So I guess let's do this. Let's say if array RC is equal to array RC minus 1. So last time we assigned that to its own variable, and we assigned this to its own variable. This time I thought let's just put them right in the if statements. So what I'm saying is let's look at this location and let's get the value and let's compare it to the location whose column is 1 smaller. And remember, if your column is 1 smaller, that's the location to the left. And if we see that those two are equal, then we can return true because we know that the value is touching another that's the same. So now we just have to do that in the other three directions. So instead of column -1, let's do column +1. That'd be checking to the right. And if we wanted to check the location above the 1, that would be r -1. You can see here, if I'm in row 3 and I look at row 2, if I make the row number smaller, that would be like looking up. And if I wanted to look down, that would be like adding 1 to the row. So now each of these if statements checks in one direction. And as soon as you hit a return statement, your method exits immediately. So if I make it through all these if statements and I've never exited, that must mean that none of those values were the same. And so I can return false because I know my location isn't next to a value that's the same as it. And so that would be sort of a nice short solution to that problem. Okay, I hope that this was helpful. If you have more questions, please email me. I hope your learning is going okay. This week, hopefully you can apply some of these ideas in a more fun setting. Good luck, everybody.